Hello, and welcome to the Encore Research Group podcast, where we encourage community research and education with weekly podcasts. I'm your host, Benton Loeyball, and this week we're talking about lipoprotein a, an inherited risk factor for heart disease. LP a, the little Hellfire engine that could kill you. I've been watching horror films lately, so before we get into lipoproteins, let's talk about blood. Blood is watery and kinda gross, but very useful. I'd like to think of the bloodstream as a highway we use to transport nutrients, cells, molecules, water, and waste to and from all the cells in the body. One problem with blood is that it can't transport things that don't dissolve in it very well. Fats, also called lipids, don't dissolve in water, a lesson I think we all learned with the old oil and water demonstration from elementary school. Because of this, the body bundles lipids into little packages that can dissolve in watery blood. These packages combine water-repelling lipids with special proteins that organize them so they can flow through the blood. These lipid protein packages are called lipoproteins. They have more functions than just transport, but that's the one we're going to be focusing on today. Now, lipoproteins are very neat. The outside of it is a membrane very similar to a human cell. The inside is a mix of fatty lipids, including triglycerides and cholesterol, and the proteins hold everything together. Lipoproteins travel through the bloodstream carrying important lipids to all the cells all over the body. They can be sorted by size and density, but density is defined a little differently here, more like buoyancy. Imagine a pot of water. Olive oil is almost entirely made of lipids, and if you pour it into the pot of water, it floats on the surface because it's low density. A steak also contains a lot of fatty lipids, but there's also a ton of protein in steak. Toss it into the pot of water and it sinks and becomes gross and ruined, but it's high density. Lipoprotein density is more about the ratio of lipid to protein. Even more fascinating is that the ratio of lipid to protein can change over time. A very low-density lipoprotein, or VLDL, will deliver triglycerides, a type of lipid, from the liver to the cells, lose some density, and may become an intermediate-density lipoprotein, or IDL. These are proportionally higher in cholesterol. An IDL may deliver more lipids to become a low-density lipoprotein, or LDL. LDL is the primary transporter of cholesterol through the body and delivers it to cells which use cholesterol for some essential purposes, including maintaining the membrane that surrounds cells. High-density lipoproteins, or HDL, work in reverse. They transport cholesterol from the cells back to the liver and get larger and larger and lower in density as they pick up more material. Lipoproteins aren't just determined by their size, however. Connected to the lipoproteins are other special proteins called apolipoproteins, with apo meaning next to or away. These determine how lipoproteins form, act, are recognized, and are broken down. One dangerous lipoprotein variant is apolipoprotein a, usually shortened to APO-a. When this attaches to an LDL-like particle, it's called LP-a. Since the names are important and the letter A is common in this space, it's usually pronounced with that little, LP-a. LP-a is bad news. When APO-a attaches to LDL, everything changes. The density of LP-a changes and it becomes more likely to clog the bloodstream. High amounts of low-density lipoproteins, including LP-a, can cause a lot of damage to the cardiovascular system, increasing chances of a serious cardiovascular event like cardiovascular disease, heart attack, and stroke. Even worse, the body can't break down LP-a the same way it does LDL, so the problems of high or bad cholesterol are compounded. Because of this, classic methods of controlling cholesterol, lifestyle changes like diet and exercise, statins, and other medications, typically have no effect on LP-a levels. High LP-a is a serious health problem, affecting around 20% of people. Levels of LP-a in the bloodstream can vary by up to 1,000 times from person to person. The highest levels are seen in Black and South Asian populations. As stated earlier, LP-a levels are unaffected by normal risk factors. Instead, LP-a is genetically controlled. If your parents have elevated Lp(a), it's likely you will too. The problem is one of several genetic mutations that affect the amount of Lp(a) created. Now, as we discovered earlier, Lp(a) doesn't break down the same way as normal LDL, so levels are primarily determined by the rate you produce it. So what can we do if we have high Lp(a)? As unintuitive as it sounds, diet and exercise are still good options. This isn't because they affect Lp(a) levels, but because a healthy lifestyle can help protect your heart. Medications that protect the cardiovascular system may also be protective against high Lp(a) levels. Currently, in extreme cases, some patients undergo a process called lipoprotein apheresis. This is where the blood is removed from the body and lipoproteins are physically separated from the blood before it's returned to the body, just like a good horror movie. Clinical trials are investigating methods of enhancing the body's ability to break down Lp(a) or disrupt production of Lp(a). Production may be targeted by disrupting the body's ability to produce ApoA. Consider joining a research study to help find a new treatment option for high Lp(a). Also, with Lp(a) Day approaching on March 24th, you can now impress all your friends with your new pedantic vocabulary. Thanks for joining us on this week's episode. If you'd like to know more, all of our sources are linked in the podcast description. You can also visit our website at encoredocs.com. That's ENCOREDOCS.com. Encore Research Group has been involved in clinical research for over 25 years. We have 7 clinical research sites across Florida, including 2 Phase 1 units. If you're in Florida, join us at sites in Northeast Florida and on the Nature Coast. If you're outside of Florida or South Georgia and are interested in joining a clinical trial, head over to clinicaltrials.gov. For more great content, including discussions by physicians and clinical research experts, check out the MedEvidence podcast. My name is Benton. Thank you for joining, and we'll see you next week.